Okay, so what we're planning on working on today are irrational numbers. All right, and irrational numbers, as we discussed in class today, those square roots, all right, that are not perfect squares. Square root of 70, okay, square root of 110, square root of 95, square root of 80. All of those are irrational numbers because they are not perfect squares. All right? Square root of 100 equals 10. That is a rational number. Okay? Square root of 25 equals 5. That would be a rational number because those square roots work out for us. Okay? These are perfect squares. These do not. So the question is, all right, what we're practicing today is what can we do with these irrational numbers, these irrational square roots, instead of just leaving them alone. Obviously, we don't do that. All right, so if we take one of them, for example, square root of 110, what we want to do is to see if we can break it down, all right, into some smaller factors, into some perfect squares to simplify it. Okay, so if we look at 110 itself, that's made up of the factors. We can do 2 and 55. All right, we can go 10 times 11. We can go 5 times 22. None of those numbers are perfect squares. Okay, none of those can I take an exact square root from. All right, so for 110, we can't do anything with it. All right, so it's ASAP. That's as simple as we can make that. That's as simple as we can make that. All right, square root of 80. Okay, can we break the square root of 80 down? Well, we can do 4 times 20. We can do 8 times 10. We can do 2 times 40. We can do 5 times 16. We got lots of them. All right. Are any of these using a perfect square? Yes. This one and this one. Okay. I'm going to go ahead and choose this one. All right. So what we can do is we can replace the square root of 80 with the square root of 16 times the square root of 5. Square root of 16 for radical 5. Okay. I cannot break the number 5 down any smaller. That's a prime number. So now the square root of 80 is simplified. All right, that's as simple as we can make it. 4 square roots of 5. That's what we'd like you to be able to do today. All right, is to take a square root, an irrational one, and see if you can simplify it by breaking it down into its smaller factors. All right, take this a step farther. What is the square root of, let's say, 120y squared? Okay. So right off the bat, we can break that down into its two factors, its numbers and its variables. Okay. So the square root of 120 is not a perfect square. So what we're looking for are some perfect squares. So we could do 12 times 10. We can do 2 times 60. We can do 3 times 40. We can do 4 times 30. 5 times 24. We got lots of choices. Okay, 6 times 20. 8 times 15. We can just keep going, and I think that might be it. And the only one that I'm seeing a perfect square in is this one right here. Okay, So we want to replace this as the square root of 4 times the square root of 30 times the square root of y squared. Okay, well, in class, that's a 2 square roots of 30. The square root of y squared is y. And we proved that in class in your notes. Okay, the square root of y squared is y. So now to clean that up, we want to move all of our squares out front. So 2, we're going to move the y out front here. And then we're going to keep the square root of 30. The square root of 30, we could break down 3 times 10 and 2 times 15 and 5 times 6. None of which are perfect squares. So we can't do anything here. So we would stop. That one is ASAP. All right. So we're factoring our square roots out. Factoring out our square roots. Now that's just the first half of your homework assignment. Okay? First half. Now the second half of your homework assignment, all right, we're going to get into our fraction side of this. Because we've been seeing a lot of fractions. And the big question is, can we take the square root of a fraction? And the answer to that is yes. We proved in class, all right, that the square root of 81 over 100 is exactly the same thing as the square root of 81 over the square root of 100, which equals 9 over 10. Okay, so again, we would get to that point and we would say we're ASAP there. All right, so obviously not everything's going to work out perfect. So if we do the square root of 40 over the square over 40 50s. So we got the square root of 40 over the square root of 50. Well, this is the square root of 4 times the square root of 10. This one is the square root of 25 times the square root of 2. And again, hopefully at this point we're getting a little better at catching our perfect squares. So the square root of 4, that would be 2 square root of 10. And the square root of 25 is 5 square roots of 2. Ten and 2, can't go any farther. Can't break those down any lower. So we would consider that to be ASAP. All right. We can always throw in the variables. So we would have the square root of 9y squared over 100. All right. So we got the square root of 100 on their denominator. We would have the square root of 9 and the square root of y squared on top. Okay, and again, that break, we broke those apart. That's what we did earlier on this previous problem. Okay, simply the same thing we did here, where we pulled the numbers in one, put the numbers under one square root, put the variables under the other square root. Square root of 9 is 3. Square root of y squared is y. Square root of 100 is 10. Okay? ASAP. Yes, it's new, and yes, it requires some thinking on your part. Do the best you can, and we'll go over any questions you have in class tomorrow. All right? Good luck, and have a good night.